Welcome everyone. In this lecture we are going to see the TDMA, time division multiple access, the pre-assigned TDMA and demand assigned TDMAs. The pre-assigned TDMA, an example of this network is the common signaling channel for the SPADE networks. The frame and burst formats we see in the diagram, and the CSE, common channeling signaling channel, can accommodate up to 49 earth stations in the network plus one reference station, making a maximum of 50 bursts in a frame. All the bursts are of equal length. Each burst contains 128 bits and occupies 1 millisecond time slot. Thus, the bit rate is 128 kbps and the frequency bandwidth required for common signaling channel is 160 kilohertz. We can see here the frame and bit formats for the common signaling channel used for the SPADE systems, and this is for the TDMA has been given 50 milliseconds frame is given. In that, for the R is for the reference burst will include having the time slot of 1 millisecond. This is the guard time slot, code recovery. This is for bit rate and unique word, and this is the data burst, again having the same time slot of 1 millisecond. How we can see that this is the bit timing recovery, guard time, this is carrier recovery, bit time recovery, unique word, and this is for signaling unit, and this is data parity. So according to the number of bits has been also given here. For total of bits for this will be given, that is for 128 bits we can see. The signaling unit, that is the section of the data burst which is used to update the other stations on the status of the frequencies available for the SCPC calls, and it also carries the signaling information. This is the signaling unit is only at the data burst and having the 48 bits, which will be used to update the other stations on the status of the frequencies available. Another example of pre-assigned TDMA frame format is the Intelsat frame, and in the Intelsat system, pre-assigned and demand assigned voice channels are carried together, but for clarity only pre-assigned traffic burst that we can see here. The traffic burst is subdivided into time slots termed satellite channels in the Intelsat terminology, and there can be up to 128 of these in a traffic burst. So this is given for 2 milliseconds frame traffic burst is given, that is for satellite channel or given. So this is sample 1, sample 2, bit numbers are also given here, and for the terrestrial channel pre-assigned TDMA frame in the Intelsat system is given here. So each satellite channel is further subdivided into 16 time slots termed as terrestrial channels. You can see here these are again divided into 16 time slots which are called as terrestrial channels. First, the frame is divided into the satellite channel which is having the preamble, traffic burst, and each satellite channel is further divided into 16 slots, and that is terrestrial channels. So each terrestrial channel carrying one PCM sample of an analog telephone signal, and QPSK modulation is used, and therefore there are 2 bits per symbol. Thus each terrestrial channel carries 4 symbols, or we can say that 8 bits. Each satellite channel carries 4 into 16, 64 symbols, and at its maximum of 128 satellite channels, the traffic burst carries their maximum of 128 satellite channels. One satellite channel has 64 symbols, so that total of the traffic burst carries the 8192 symbols. The PCM sampling rate is 8 kilohertz, and with 8 bits per sample, the PCM bit rate is 64 kbps. Each satellite channel can accommodate this bit rate. Where input data at a higher rate must be transmitted, multiple satellite channels are used. The maximum input data rate which can be handled is 128, that is satellite channel into 64 kbps. symbols per satellite channel is equal to 8.192 Mbps. The Intelsat frame is 12832 symbols, or it is 2,41,664 bits long. The frame period is 2 milliseconds, and therefore the burst bit rate is 120.832 Mbps. Pre-assigned and demand-assigned voice channels can be accommodated together in the Intelsat frame format. The demand-assigned channels utilize a technique known as digital speech interpolation (DSI). The pre-assigned channels are referred to as digital non-interpolated channels. The pre-assigned channels are digital non-interpolated channels, and demand-assigned channels are digital speech interpolation channels. So the demand assigned TDMA. With TDMA, the burst and subburst assignments are under software control compared with hardware control of the carrier frequency assignments in FDMA. Consequently, compared with the FDMA networks, the more flexibility in reassigning channels, and the changes can be made more quickly and easily. A number of methods are available for providing traffic flexibility with TDMA. The burst length assigned to a station may be varied as the traffic demand varies. A central control station may be employed by the network to control the assignment of burst length to each participating stations. Alternatively, each station may determine its own burst length requirements and assign these in accordance with a pre-arranged network disciplines. As an alternative to burst length variations, the burst length may be kept constant and the number of bursts per frame used by a given station varied as demand requires. In one of the proposed systems, that is by CCIR, the frame length is fixed at 13.5 milliseconds. The basic burst time slot is 62.5 microseconds, and station in the network transmit information burst varying in discrete steps over the range of 0.5 milliseconds or 8 basic bursts to 4.5 milliseconds, that is 72 basic bursts per frame has been given. So demand assignment for the speech channel takes some advantages of the intermittent nature of the speech. So speech interpolation and prediction that we see. Because of the intermittent nature of speech, a speech transmission channel lies inactive for a considerable fraction of the time it is in use. A number of factors contribute to this. A talk listen center of a normal two-way telephone conversation means that transmission in any one direction occurs only about 50% of the time. In addition, the pauses between words and the phrases may further decrease this to about 32%. If further allowance is made for end party, delays such as the time required for a party to answer a call, the average fraction of the total connect time may drop to as low as 25%. The fraction of time a transmission channel is active is known as the telephone load activity factor. And for system design studies, the value of 0.25 is recommended by Committee Consultative International Telegraphy at Telephonic, although higher values are also used here. The point is that for a significant fraction of the time, the channel is available for the other transmissions, and advantage is taken for this in a form of demand assignment known as digital speech interpolation. Digital speech interpolation may be implemented in one of two ways, these being digital time assignment speech interpolation, that is digital TASI, and speech predictive encoded communication, SPEC. So we'll see the first, that is digital TASI, digital time assignment speech interpolation. The traffic burst format for an Intelsat burst carrying demand assigned channels and pre-assigned channels we will see in detail with the diagram. And the demand assigned channels utilize digital TASI, or what is referred to in the Intelsat nomenclature as DSI, digital speech interpolation. There are the block labeled as interpolated. The first satellite channel in this block is an assignment channel which is labeled as DSI-AC. No traffic is carried in the assignment channel. We'll look for the Intelsat traffic bus structure. Into this is the interpolated frame, pre-assigned non-interpolated, that is DSI-AC. DSI assignment channel which is having 128 bits, n satellite channels, and one channel is having 16 8-bit samples per satellite channel, that is terrestrial channel. Satellite channel, one satellite channel is subdivided into 16 slots which is terrestrial channels. So this DSIAC is assignment channel and no traffic is carried by this assignment channel. See, there is no any traffic carried by the assignment channel. So it is used to transmit channel assignment information, as we will see here. The outline of the DSI system will shown in the next diagram, that how it will get outlined. Basically, the system allows n terrestrial channel to be carried by m satellite channels, where n is greater than m. For example, in the Intelsat arrangement, n is equal to 240 and m is equal to 127. As on each incoming terrestrial channel, a speech detector senses when speech is present. The intermittent speech signals being referred to as the speech spurts. A speech spurt lasts on average about 1.5 seconds. A control signal from the speech detector is sent to the channel assignment unit, which researches for an empty TDMA buffer. So assuming that 1 is found, the terrestrial channel is assigned to this satellite channel and the speech spurt is stored in the buffer ready for transmission in the DSI subburst. A delay is inserted in the speech circuit to allow some time for the assignment process to be completed. However, this delay cannot exactly compensate for the assignment delay and the initial part of the speech spurt may be lost. This is termed as the connect clip. That some time slot will get lost, which is called as connect clip. In the Intelsat system, an intermediate step occurs where the terrestrial channels are renamed international channels before being assigned to a satellite channel. At the same time as an assignment is made, an assignment message is stored in the assignment channel buffer, which informs the receive station which terrestrial channel is assigned to which satellite channel, which will have information to receive stations with to which the terrestrial channel the assignment of the satellite channel is given. Once an assignment is made, it is not interrupted even during the pauses between the spurts, unless the pause times are required for another DSI channel. This reduces the amount of information needed to be transmitted over the assignment channel. At the receive side, the traffic messages are stored in their respective satellite channel buffers. The assignment information ensures that the correct buffer is read out to the corresponding terrestrial channel during its sampling time slots. So during speech pauses, when the channel has been reassigned, a low level noise signal is introduced at the receiver to simulate a continuous connection. It has been assumed that a free satellite channel will be found for any incoming speech spurt, but the course there is a finite probability that all channels will be occupied and the speech spurt will lost. Losing a speech spurt in this manner is referred to as freeze out, and the freeze out fraction is the ratio of the time the speech is lost to the average spurt duration. It is found that a design objective of 0.5% for a freeze out fraction is satisfactory. This means that probability of a freeze out occurring is 0.005%, which is very less. Another source of signal mutilation is the connect clip mentioned, that is the loss of the spurt. Again, it is found that the clips longer than about 50 milliseconds are very annoying to the listener. An acceptable design objective is to limit the fraction of clips which are equal to or greater than 50 milliseconds to a maximum of 2% of the total clips. In other words, the probability of encountering a clip that exceeds 50 milliseconds is 0.02. The DSI gain is the ratio of the number of terrestrial channels to number of satellite channels, or n by m. The DSI gain depends on the number of satellite channels provided as well as the design objectives. Uh, in this we can see that the terrestrial channels are given from 1 to up to 140. This is the speech detector. Some delay will be introduced, and here is the assignment control. Assignment messages will be given to the assignment channel, and this is the TDMA buffer to which given. This is the satellite channel 1 to up to so on 128, and from the DSI channel has been given this is the digital speech interpolation channel. And digital speech interpolation, DNI, is the digital non-interpolation. So speech predictive encoded communications, the second type is. This block diagram we will see here, and in this the incoming speech signals are converted to a PCM multiplex signal using 8 bits per sample quantization, with 64 input lines and sampling at 125 microsecond. The output bit rate from the multiplexer is 8 into 64 by 125 is 4.096 Mbps. The digital voice switch following the PCM multiplexer is time shared between the input signal. It is voice activated to prevent transmission of the noise during the silent intervals. So when the zero order predictor receives a new sample, it compares it with the previous sample and transmits the new sample only if it is differ from the preceding one by a predetermined amount. It means that if there is a slight change, then only it will be transferred. These new samples are labeled unpredictable PCM samples, and for the 64 channels, a 64-bit assignment word is also sent. A logic 1 for the assignment word means that a new sample was sent, and a logic 0 means the sample was unchanged. At the receiver, the sample assignment word either directs the new sample into the correct channel slot, or it results in the previous sample being regenerated in the reconstruction decoder. The output from this is 4.096 Mbps PCM multiplex signal, which is demultiplexed in the PCM decoder. By removing the redundant speech samples and silent periods from the transmission link, doubling in channel capacity is achieved. The transmission is at 2.048 Mbps for an input-output rate of 4.096 Mbps. An advantage of the SPEC method over the DSI method is that freeze out does not occur during the overload conditions. During overload, sample values which should change may not. This effectively leads to a coarser quantization and therefore an increase in quantization noise. This is subjectively more tolerable than freeze out. We can see that this is the SPEC transmitter receiver, where the analog voice inputs are given. PCM coder multiplexer input duplexer has been given. 64 channels has been assigned here, 1 2 3 4 6 4. Digital voice switch, zero order predictor, assignment recirculation unit, error control, and at the output time division multiplexer has been given. This is the PCM decoder. This is B section is the receiver here. This is the transmitter. So downlink analysis for digital transmission we will see here. The transponder output power and bandwidth both impose limits on the system transmission capacity. With TDMA, TWT backoff is not generally required, which allows the transponder to operate at saturation. One drawback arising from this is that the uplink station must be capable of saturating the transponder, which means that even a low traffic capacity station requires comparatively large power output compared with what would be required for FDMA. As with the FDM or FDMA system analysis, it will be assumed that the overall carrier to noise ratio is essentially equal to the downlink carrier to noise ratio. So with a power limited system, this carrier to noise ratio is one of the factor that determines the maximum digital rate. RB is C by N0 minus EB by N0. That EB by N0 is determined by the required bit error rate. For example, the bit error rate of 10 raised to minus 5 and E by N0 of 9.6 dB is required. If the rate RB is specified, then the C by N0 carrier to noise ratio is determined, and this value is used in the link budget calculations. Already we have seen the link budget. So alternatively, if the carrier to noise ratio is fixed by the link budget parameters, the bit rate is then determined with RB is equal to C by N0 minus E by N0. The bit error rate is also constrained by the intermediate frequency bandwidth, IF bandwidth. The ratio of bit rate to IF bandwidth is given by RB by BIF, and which is equal to M by 1 plus rho, where M is equal to 1 for BPSK and M is equal to 2 for QPSK, and rho is the roll-off factor. The value of 0.2 is commonly used for the roll-off factor, and therefore the bit rate for a given bandwidth becomes RB is equal to M into BIF by 1.2. So in this we have seen that the pre-assigned TDMA, then for the demand assigned TDMA, in which we have also seen the DSI and SPEC frame formats for the TDMA. So also we have seen the speech predictive coded communication, and after that this is the analysis for the digital transmission. For this also we have seen here. In the next lecture we will see for the TDMA, that is for satellite switch TDMA, and for the onboard processing.